Good morning, students. I am Pramod Joy, your computer science teacher. And in this video, we are going to deal with the data structure from the unit number 1, CTP, Computational Thinking and Programming 2. And this is the very first video related with the data structure. Shall we start? We can start from the definition of the data structure. A data structure is a logical way of organizing data that makes them efficient to use. Or a data structure is a specialized format for organizing, processing, retrieving, and storing data. Or in other words, a data structure is a collection of data values, the relationships among them, and the functions or operations that can be applied to the data. Or a data structure is a particular way of organizing data in a computer so that it can be used effectively. Data structures can be classified into two: simple data structure and compound data structure. And the examples of simple data structures are arrays and linear list. Compound data structure can be again classified into two: linear and non-linear. And the examples of linear data structures are stack, queue, and linked list. And example for non-linear data structures are tree. Operations on data structure. The basic operations that are performed on data structures are as follows: insertion, deletion, searching, traversal, sorting, and merging. First, we are going to discuss about the simple data structure, linear list or arrays. Linear list or arrays stores a collection of objects of a certain type. And the very first operation related with the linear list, that is searching. And there are two types of searching: linear search, binary search. In linear search, each element of the array is compared with the given item to be searched for one by one. Binary search requires the array or the list to be in a sorted order. Linear search program is explained below. Binary search. Binary search program is explained below. Insertion. Insertion into a linear list or an array. Insertion of new element in an array or a linear list can be done in two ways. If the array is unordered, the new element is inserted at the end of the array. If the array is sorted, the new element is added at appropriate position without altering the order. And to achieve this, rest of the elements are shifted. Insertion. How to insert an element into a linear list or an array is explained with the help of a program. Shifting of elements is an expensive process and should be avoided if a better algorithm is available. Python makes available a better algorithm called bisect, available in bisect module. The insort function of bisect module inserts an item in the sorted sequence, keeping it sorted. Bisect module works on a sequence arranged in ascending order only. The bisect module also offers another function, bisect function, that returns the appropriate index where the new item can be inserted to keep the order maintained. Program that explains the insertion using bisect is given below. Deletion. The element to be deleted is first searched for in the array using one of the searching techniques. If the search is successful, the element is removed and the rest of the elements are shifted so as to keep the order of the array undisturbed. Deletion. Program to perform deletion is explained below. Traversal. Traversal involves processing of all elements one by one, and the program is explained below. List comprehensions. A list comprehension is shorthand for a loop that creates a list. A list comprehension is usually shorter, more readable, and more efficient. An example is given below. The very first example shows with the help of a for loop how the elements is added in a list. The same example is written with the help of list comprehension below. Another example of list comprehension. List comprehensions are, although useful, it should not be used to check multiple conditions. Advantages of list comprehension includes code reduction and faster code processing. Nested list. A list that has one or more lists as its elements is a nested list. Examples are given below. Two-dimensional list. A two-dimensional list is a list having all its elements as the list of the same shapes. Example is given below. A regular two-dimensional list is a list having list as its elements and each element or list has the same shape. That means the same number of elements. Regular two-dimensional lists are the nested list with these properties. All elements of the 2D list have the same shape. The length of a 2D list tells about the number of rows. The length of a single row gives the number of columns. Ragged list. A list that has list with different shapes as its elements, called a ragged list. An example is given below. An example for how to create a two-dimensional list is given below.